All right, this is part 2 of the 32 tall project. Again, we're going to skip the cylinder, talk about that individually a little bit later this semester. The next part we're going to cover is the cover. It is brass. The thing to note about the cover is that it is a requirement to use configurations for the cover and the valve plate here. The valve plate and the cover are required to be done in configurations because they're the same part, but this one has 9 holes in it. The inboard head. Pay particular attention to this. The inboard head is aluminum. Here's the thing to note. This is a circular feature, and this is a circular feature. This is not a hole. This is a boss. And if I look at this view, you can see there's a raised area here. That is this feature. It's not a hole. It's a boss. The other issue, this right here, the drill 41, drill number 21, depth a quarter, tap 3/16 40. That is a non-standard thread. This is a specialty thread. SolidWorks does not have the ability to do that thread. So here's what you're going to do. Take good notes on this because this is a huge deduction if you don't do this. You are going to do a little bit of sleuthing on the internet. I'm sure you know how to use Google. You need to find out what the decimal equivalent of 3/16 is, and you need to find a standard thread that's close to 3/16. Now, are you going to be able to find a standard thread that's close to 3/16 and 40 threads per inch? No, but you can get close. So that's your job. And there are multiple instances of this. Anytime you see 3/16 40, you do not use it. You need to determine what you're going to use that's close to that, and that's going to be your standard, and you're going to stick to it through this whole project. Outboard head. Same here as over here. This circular feature is not a hole. It's a raised boss if you look at this view. It's like looking straight down from an airplane at a series of silos on a farm. To the person in the plane, it looks like a pool, but it's not a pool. There's nothing particularly complicated about this particular part. These holes here with these hidden lines, those are countersunk holes, and here's the indication here. It's for a number 256 threads per inch. The steam chest. There's a couple of issues with the steam chest, and there are 4 views on this. Steam chest is aluminum. Outside of this weird thread call out, there's a couple of missing dimensions on this. First would be this radius right here. Technically, it's not called out appropriately, but there is a note in this. You see this circle right here? That really does tell us what this radius is. How does it do that? Well, it tells me that this is 11/32 from here to here. And if it's 11/32 from here to here, then it's 11/64 from here to here. And if this distance is also the diameter of this circle, if this is 11/64, then this is 11/128 for this radius. This is illegal. You're not supposed to do this. You're not supposed to dimension off of hidden lines. They did. The nut. The nut is just a rectangle piece of brass with a number 256 hole drilled in it. The valve plate we already talked about. That's required configuration along with the cover. The valve rod. External threads. SolidWorks currently allows you to do external threads in Thread Wizard. I don't care if they're there or not. You could just as easily do what this person did, insert a note. You don't have to do external threads. It's cool looking, but it also slows your computer down because of the math required. The valve. Here is the view. Here. There's 4 of them. There's the left, front, right, and we'll call this the bottom. This view here shows this little rectangle. And the only other place you'll see that little rectangle is in this view here. Ignore these call-outs. Do you see this little feature right here? That is the depth of this cut because this is this. And if you go through in your head what these views are, you can see that that's what this was. They should have shown this in this view as well, but they did not. This notch is this rectangle here, and this notch is this rectangle here. And is that easy to see? It is once you've gotten used to seeing 3-dimensional objects in your head and rotating them around. 2 pack nuts, one for the piston, one for the valve rod. Brass or aluminum, doesn't make any difference. Look at this, 3/16 40. Don't do it. Telling you now, don't do it. Out of 60 people, 10 of you will do it anyway. And I have a special spot on my grade sheet to deduct huge points for doing this, even though I tell you for probably a total of 5 minutes not to do it. You're going to do it anyway. And so, you know, those are the people that I don't want to employ. The Eccentric is steel, so 1020. The crank screw, steel, also 1020. I'm skipping a couple things. So the link, make that out of brass. The pin, also brass. This rod here is brass. Ignore the wire, don't worry about it. You could even not drill this hole and it would be okay. We're going to hold this steam engine together with mates, not piano wire and washers. This pin here, I don't know what you want to call this. You could call this pin number 2 or something. This is also brass. I'm skipping the piston rod, the eccentric strap, and the connecting rod assembly on purpose. We're going to cover those last. The piston. This is not a hard part, but what people typically do, they give me this call out back to me in your drawing package. Oil grooves. A certain dimension by a certain dimension approximate. Here's the thing. If you draw this, it is no longer approximate. It's exactly what it is, and I want to know what it is. So does the person that's trying to make this using your plan set. They are not approximate. They are exactly what you define them to be, and I want you to tell me that. Also, there is really not a location of these 3 grooves. The grooves go all the way around. You see this dashed line? That represents the bottom of the groove. I want to know where these grooves are, how wide they are, and how deep they are. Not approximate. Flywheel. See this option right here? That is not an option. This is the flywheel required. I'm going to create a final video for the last 3 parts.